Welcome, folks. Today we're going to be talking about tie lines and solid solutions.
With a material at a certain concentration of elements and a certain temperature, you can use a phase diagram to see what phases will be present, how much of each phase there is, and what those phases are composed of.
Now this topic could get a little boring for some of our younger audiences.
We can use the example of a web student's backpack, which can either be filled with juice or books depending on where they are and how warm it is.
In order to figure out the concentration of juice versus the concentration of books in a student's backpack, we'll use the inverse lever arm equation.
So here we have our phase diagram. On the x-axis we have location in regards to percentage of the way towards the rock from the president's house. And on the y-axis we have the outside temperature. Now let's use this diagram. For example, let's say we're 30% of the way to the rock and it's 30 degrees out. You can see here our backpack's going to have all books. But if we're 75% of the way to the rock and it's 90 degrees out, we're going to have all juice. You can see the line where it changes from all books and all juice drawn out here. This middle region, you're going to have some of both. For example, let's say you're at 40% of the way to the rock and it's 60 degrees out. This horizontal line here at 60 degrees is called the tie line. Now our point is at 40%. The line that corresponds, or the point that corresponds with the juice line here is at 50% of the way to the rock. And the point that corresponds with the book line is at 10%. So what we're going to do is we're going to use the inverse lever arm equation, and we're going to take 0.5 minus 0.4, representing this part of the line, divided by the total length of the line, 0.5 minus 0.1, to get a number of 0.25. Now since it's the inverse lever arm equation, this segment of the line corresponds with how much books we have in our backpack. Oh man, that's hard to get off. This means here that we have 25% books in our backpack, which leaves the other 75% to be juice.
And now for another example.
We can also think about the concentration of nerds versus girls, depending on where you are and how much fun you're having.
For example, if you were in New York City, you would have lots of girls on various levels of fun. Also, at high levels of fun, there would be girls no matter where you're at.
In this phase diagram, we have on the x-axis the distance from New York City to Webb in percent distance, and on the y-axis we have amount of fun, not so much to a lot of fun. So we draw a tie line at around a moderate amount of fun, and let's say we're 25% of the way from New York to Webb. Our tie line equation, our inverse lever arm equation, would consist of the right part of the tie line, if we're finding the percent girls, 0.8 minus 0.25, divided by the length of the entire tie line, 0.8 minus 0.2. This will yield us 0.92, or 92% girls, and 8% nerds.
Wow, those are some big juice boxes.
This here is a pie line.
Hey guys, this here is a toe line, but we're talking about tie lines. Now I hope you all learned a little something today about them.